Hello students, welcome to Ishwari Taniksha channel. Students, in this video we are going to see conversion reactions. So usually you would have seen in organic chemistry. So reactions will be given like this. A is converted to B and on the arrow the reagents will be given bromine in the presence of diffuse sunlight, or bromine in the presence of CCl4, or bromine in the presence of FeCl3 and condition is dark. So such type of question will be given and you have to find what is the product which is formed. So this is very useful in conversion reactions. So let us see here. So I have taken three reactions and three different reagents. Bromine in the presence of diffuse sunlight or UV light, and bromine in the presence of carbon tetrachloride, and bromine in the presence of FeCl3 and dark condition. So what are the products formed here? So let us see. So students, first reactant is present. So suppose when you see bromine in the presence of diffused sunlight, so it can be given as UV light or the symbol can be given like this, diffuse sunlight. So what you have to do is, bromine in the presence of diffuse sunlight, it will undergo substitution reaction, free radical substitution reaction. So I'll write here. So this is free radical substitution reaction. So if it is free radical substitution reaction, always remember that you should not touch the double bond. So free radical, see where a stable free radical will be formed. So here always remember, next to the double bond, the carbon which is present here. So suppose if you form free radical here, so this free radical can be stabilized by this double bond. Therefore, stable free radical will be formed here. So you can form free radical here or here, it is one and the same. So since it is substitution reaction, so here hydrogen will be replaced with bromine. So the answer will, the product here will be, so you will write the double bond here and bromine will be attached here. So this is the product. So this is how you should find out. So always remember, if it is bromine in the presence of diffuse sunlight, it is free radical substitution reaction. So substitution meaning is hydrogen will be substituted by bromine. Since it is free radical, see where stable free radical will be formed. Always next to the double bond, the free radical which is formed will be stable because it is stabilized by resonance. So next we will see, if a reactant is treated with bromine in the presence of CCl4. So this is test for unsaturation. So always you have to break the double bond and you have to add one bromine here and one bromine here. So this is a addition reaction. So always in addition reaction we are going to break the double bond. In substitution reaction you should not touch the double bond. In substitution reaction, substitute hydrogen with bromine. So what is this? So I'll write here, this is addition reaction. So in addition reaction, what you are going to do is, you are going to break this double bond, add one bromine atom to this carbon and another bromine atom to this carbon. So the product here, it will be CH2, single bond CH2, and bromine is added to this carbon and one bromine is added to this carbon. So this is the product. In the third one we will see. So we are taking a reactant, we are treating with bromine in the presence of FeCl3 and the condition is dark. So then what type of reaction this will show is, this will show electrophilic substitution reaction. Again, substitution reaction. So what did I say? Substitution reaction meaning? Substitution meaning is you should not touch the double bond. So you have to substitute hydrogen with bromine. So where I have to substitute? So here you have hydrogen. On each carbon atom one hydrogen is present. Here one hydrogen, here one hydrogen, here here one hydrogen, here one hydrogen, and here 3 hydrogen atoms are there. So where I have to substitute? So since this is electrophilic substitution reaction, in this reactant which is rich in electron, you know that benzene ring is rich in electron because of presence of the pi bonds. Because of the presence of double bond, benzene ring is electron rich. Therefore electrophile will add on the benzene ring. But where I have to add on the benzene ring? Whether I have to add here, 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 where I have to substitute? In these places. So see this. So here this group is ortho para directing. Therefore bromine will be substituted at the ortho position. So here we have 2 ortho position, and this is meta position and this is para position. So you have to substitute the electrophile at the ortho position and para position. So here the product will be, so here you will get like this. So one bromine at the ortho position and CH3, and one bromine at the para position. So these are the products which is formed. So always remember, so bromine, when you see, you will get confused what I have to do, whether I have to break the double bond or I have to remove the hydrogen atom. So in order to prevent that confusion, so always remember, bromine in the presence of diffuse sunlight, it is substitution reaction. What kind of substitution reaction? Free radical. So which free radical is more stable, you have to check. Since here double bond is there, the free radical which is formed next to double bond will be stable, because this double bond is involved in resonance. This will stabilize. And here in the second one, bromine in the presence of CCl4. So this undergoes addition reaction. So addition reaction means wherever you see the double bond, break the double bond, add bromine to one carbon and add one more bromine to other carbon atom. If you see bromine in the presence of Lewis acid, FeCl3 is Lewis acid, or sometimes it will be given just as Fe. So see the reagent, whether it is only Fe or FeCl3, it is one and the same. So Lewis acid and the condition is dark. Then it is substitution reaction. Substitution reaction means hydrogen you will have to replace with bromine. But what kind of substitution reaction? Electrophilic substitution reaction. Electrophilic substitution reaction meaning is this will be electron deficient. See where is electron rich area. So in this, the electron rich area will be benzene. Benzene will be highly rich in electron. So you have to substitute on the benzene ring. So where I have to substitute on the benzene ring? Because you have 3 positions. These are ortho position, these are meta position, and this is para position. Then see the group. What kind of group is present? This is ortho para directing group. Therefore electrophile will be substituted at the ortho position and para position. So the electrophile which is formed here is Br plus. So Br plus is the electrophile. So Br plus will get added to the ortho position. So here you can see ortho product, and then getting substituted at the para position. This is called as the para product. So students, I hope it is clear to you. Still, if you have any doubts, you can write in the comment section. Students, if it is useful to you, please subscribe the channel and also share this video with your friends. I'll meet you in the next video, students, with another super duper video. All the very best. Keep preparing for your examination.